Hello everyone, myself Venkatesh Naginla. Today I will discuss about IoT sensor data retrieval and analysis for effective power management in smart building because nowadays we are getting all smart buildings right. In this first we will discuss mainly about contribution of the paper. Here the main contribution is integration of IoT sensor data retrieval and analysis through a cloud environment because we don't have a power management in smart buildings more. It's like because power management is not easy as telling the watts. We have to manage. We have to face so many challenges to manage the power for smart buildings, and we need need lot of data to store. Nowadays, there is no data available in some situations, and the paper proposes an innovative approach to leverage IoT technologies. We have a lot of technologies and cloud services to address the challenges of energy management in smart buildings. As we discussed before, we have to face so many challenges, cloud services for to manage energy in smart buildings by integrating sensor data retrieval and analysis in cloud environment. We need proposed framework offers a holistic solution for optimized power consumption, and for in urban environments we enhancing sustainability for this smart buildings power management. And we will go to the next slide. It's like a primary problem discussed in this paper. The primary problem in this paper is sensor data. We have insufficient sensor data, so we have to manage that sensor data. The point is here insufficient management of sensor data in IoT enabled smart buildings, as we discussed before, and effective power management hindering because we don't have that much sensor data nowadays, because we lot of people, we have a lot of IoT devices, and we a lot of vast amount of data is generated. That's why we have to we have insufficient manage of sensor data. With the increasing of adoption of IoT devices and sensors in smart buildings, and sensors in smart buildings are will- and there's a growing challenge of managing and making sense of the vast amount of data generated. As we discussed before, a lot of amount of data is generated. Vast insufficient data management leads to suboptimal power management strategies and can impair the overall sustainability and effective of smart building operations. Exactly. Like it it will definitely affect the smart building operations because here data management is so much important and the power management too. So to we have insufficient data management, and we will discuss about later how can we manage that and what are the new one too. And here we discuss about the solution proposed in the paper. Previously we discussed primary problems, and now we will discuss about the solutions for that. The proposed solution is deployment of various sensors in smart buildings, data transmissions to a cloud server, and remote access for real-time monitoring and control. This is a good idea. To if we have remote access for real-time monitoring, we will control all this data. And in smart buildings, we can manage the power management too by using this one, by using the cloud server. The paper proposes a compression solution that involves deploying a diverse range of sensors throughout the smart building. Capture environment data such as temperature, humidity, motion, and light intensity. Yeah, we have to check all environment. like we have to check the temperature, it's cold or hot, and we have to check humidity and motion and light intensity. All we have to check, and by checking all this, we will calculate about it, and we will arrange, design the smart building according to all this temperature and humidity, etc. and etc. Sensor data is then transmitted to a cloud server located within the building's infrastructure, where it is stored, processed, and analyzed in real time. Yes, it will transmit it into cloud server. So, if the building infrastructure, we have to keep that like it gonna be stored in real time, and we have to analyze that data. Clients can remotely access the processor data and control metadata, enabling productive management of building systems and optimize of power consumption. We can we can access remotely by processing data, and we have to control like metadata. And here there is a lot of power consumption, so we have to optimize the power consumption and management. We have to manage like building systems. Like some buildings are, we have to manage that as according to, like we have to make good, we have to manage all these building systems, and by sensor data also we can manage this. Here we here before we discuss a little bit about the solution, and here we will discuss detailed information about the proposed solution. First we will discuss about sensor deployment. Various sensors including humidity, motion, sunlight, and carbon monoxide sensors are strategically placed throughout the building to capture relevant environment data. As we discussed before, like we have to check environment around the building. Is it like the sunlight is getting through the window, or like is around the building humidity is good, is carbon monoxide, and the temperature is good, and all we have to check environmental, and then we have to proceed for further. And we will discuss now about cloud server. A cloud server within the building infrastructure of facility centralized data like storage, processing, and analysis, enabling real-time insights and decision making. Like we have to processing, we have to analyze this all cloud server, and we have to storage. Like we need more storage because like lot of IoT devices. So the cloud server is main important, and real-time insights and decision make. Remote access. Clients can access sensor data and control metadata remotely via web. Yeah, clients have to access sensor data and control metadata. If they access, they can they can do better than what we expected, and they will make a change to the applications, mobile applications. Like they can change better than allowing for seamless monitoring and controlling of building systems from anywhere. As we discussed before, they can control building systems. Like if the building is not good, they can control by accessing data, and by accessing sensor data they can know that the building has some problem, and they will uh, they will do via web and some mobile applications. So for clients, access sensor data is important. And the hybrid network architecture. The proposed solution utilizes a hybrid network architecture combining grid and stellar topology to ensure reliable data transmission and connectivity within the smart building environment. Here we need hybrid network architecture combining grid and stellar topology, because by doing network architecture, like we can make better than the before, and we can solve many problems, and the smart buildings is a good. And we will discuss about the illustration of the proposed solution. Here are the some sample building I'm taking here, like from Swansea University. And if you look that building, it's you can see the building how it looks like that. and we have some data transferring to sensors, and then community monitoring, and going to use like a processing storage. First we discuss about sensors. As we discussed, it's like temperatures, carbon dioxide, humidity, light, motion detection, airflow. Here from this data to here, and we will check about this by using data, how like what is being the temperature, and how like CO2 is going, and how is the humidity, and how is the airflow is like high or like low. And we will check about motion uh, detection, all we will check. And renewable energy, like by using solar systems, like it gonna renewable energy, and it will form into rain, and it is gonna good and appliances like TV, fridge, anything we have to keep in that smart building, and there is no effect for them. And all these sensors and appliances and renewable energy, like they will go to, like we can store that information in some storage. That storage is system, and the sensors community monitoring. Like in this system we will monitor about all this, how sensors are working, and how energy is is renewable, and how we are using this one. And later next slide we will discuss about all in detail. Here smart building, this represents the core infrastructure where various sensors are deployed to monitor environment conditions. As we discussed, smart building is the core infrastructure. So to build, first we have to like the infrastructure is good, and we have to like sense we have to maintain some sensors like data sensor or something, which is deployed to monitor environment conditions. As we discussed, environment conditions like temperature, humidity, all we have to check before that. It serves as the primary hub for integrating and managing sensor network. Yes, obviously it serves as the primary hub. And within the smart building, sensors such as the temperature, motion, humidity, and light sensors are strategically placed to capture relevant data points. Yes, and the cloud server was in centrally in the flowchart. The cloud server acts as the central processing unit for the system. Yeah, this we like a cloud server is the central point to access the all data in it. Like we can get from the smart building, and it will store in a cloud server. And if some client wants to see how is the position of that, and he can access the data from cloud server, and he can know that it's good or it's going better, or we can do better by using that data. We have to store in that, and it's the central point. It receives real-time data streams from the sensors deployed through the smart building. Yes, it will come streams, and we can use those energies and we can renewable that energy. Upon receiving the data, the cloud server processing and analyze it into derivable insights. Processing data is stored securely in the cloud-based database for further analysis and further reference. Because like they we have to store data in somewhere else to check if after 5 few years we have to check is that how it's gonna made, and is it good or not, how many years it gonna be staying. So all we have to calculate by using that storage, we can calculate those. So we have to store in a cloud base. Like for another analysis and future reference, if we have to make same building, or we have to make like some more buildings according to this. So by using this data, we can make another easily. And sensor nodes are represented as interconnected nodes on the right side of the flowchart. Sensor nodes consist of various sensor devices. Yes, nodes, sensor data is very important. And because of higher IoT devices, like sensor data is like vast. We have a lot of data to like to store. So it gonna store very easily, and it's gonna like we can get information from the buildings easily by using this sensor nodes, and we can receive data. Each sensor node is responsible for collecting specific types of environment data, including temperature, motion, humidity, and light intensity. Every sensor node will responsible for collecting specific types like this motion, humidity, and also temperature. So the sensor nodes continuously monitoring their respective environment parameters and transmit the collected data to the cloud server for processing. And through interconnection, the sensor node collaboratively contribute to the component monitor to the of the smart building environment. Yeah, we have to interconnect the sensor nodes collaboratively. Because the we have checked like it will check the smart building environment. Each sensor will check the smart building environment. So we have compromise monitoring. Overall, the diagram illustrates the seamless flow of data within smart building system, from the sensors capturing environment data to the cloud server processing and analyzing it. And these are the few points about the smart building and sensor nodes and the cloud server, like how we can store the data, and how we can use that stored data for further references or future references. And we will come to the conclusion. Here the conclusion is, in conclusion, the integration of IoT sensor data retrieval and analysis presentation presents a transformative opportunity to enhance power management practice in smart buildings. Like we like in before we have like some power management challenges. By using this, we can manage the power as easy as we can. And as we move towards a more connected and sustainable future, it's important to continue exploring and implementing innovative solutions that leverage emerging technologies to address the complex challenges of urbanization and resource management. In urbanization, like we have some challenges which they faced before, but by using this problem solution, like we can solve easily by using the sustainable future, like by using the previous data, and we can implement innovative solutions for this. By working collaboratively and embracing technology advancements, we can create smarter, greener, and more cities for generations to come. Yeah, by working collaboratively, and by working this, like we can make smarter buildings than before, and it can make like a good and the environment will be good, temperature, IoT sensors, all we have to check, and we can make like mm, good than before. Thank you so much for giving this opportunity. Thank you all. Thank you once again. Have a good evening, good night.